Welcome to our fifth video on linear relations. In this one, we're going to be going over how to match an equation to its corresponding graph. So this is the type of question where you would be given a graph, and often on the PATs, this is a situation where you're given a graph, and then it's a multiple choice test where there's 4 different equations, and your job is to figure out which equation matches that graph that's given to you. So I've written out the 3 steps you need to do. The first step is to pick a point along the graph and note its x and y value. And what I mean by note is that, well, obviously it would be helpful to write them down. Once you've done that, you're going to go back to the equation, well, each equation actually that's given to you. If it's a multiple choice question with 4 equations, you would have to do it 4 times. And what you're going to do for each equation is substitute those x and y values that you just figured out into each of them. And that'll make a bit more sense when we try an example here. And then once you've done that, you're going to solve each of those equations to find out which one of them is actually correct. So let's go ahead and try a couple examples and get a better idea of what this all means. Okay, so here's our first equation, or sorry, our first graph, and we've got 3 possible equations that could match this. So our first step was to pick a point along the graph. And obviously you want to try and pick a point that's on the grid. So what I mean by that is you wouldn't want to pick something like that because that's like 2.5 and 1.5. It would make more sense to pick whole numbers, for sure. So why is my eraser not working? There we go. So it would make more sense to pick something like this point here. Now what I'm going to do is jot down the x and y values of that point. I'm just going to do that up at top here. So my x value of that point is 2, right there. And the y value, I'm just going to use a different color for that. Our y value is positive 1. Now what I'm going to do with each of these 3 equations is anytime I see an x value, I'm going to substitute it for a 2, and we're going to replace it with a 2. And then anytime I see a y value, I'm going to replace it with a 1. And let's just see what happens. First off, I'm going to replace my x's with 2's. I'm just going to write it right below each of these equations. So it'd be 2 plus 1 there. In the second equation, instead of the x here, we are going to replace it with a 2, so it's going to become 2 minus 1. And then in the third equation, where it's 1/2 times x, now it's going to become 1/2 times 2. And it's helpful just to write it in brackets like this, and that's because we know that we're using multiplication here. And then we're going to replace all of our y values with a 1. So this says 1 equals 2 plus 1. The second one, got a 1 here, and the third equation, a 1 here. Now we can take a look at what we've got. We've got 3 equations. Now that we've replaced the variables with numbers, we've got no variables left. And we're trying to find out which one of these is actually telling the truth. For example, in this first equation, it's saying 1 is equal to 2 plus 1. Is that telling the truth? Well, obviously not. 1 is not the same thing as 2 plus 1. So no, it doesn't work. Next equation, is 1 the same thing, or is it equal to 2 minus 1? Yes, definitely. So that could be our correct answer, but we should check all of the equations given because it is possible that more than one can be correct for a given point. So let's check it down here. Is 1 the same thing as 1/2 times 2, or half of 2? And in fact, that actually is true. 1 is the same thing as half of 2. So there's a bit more work required in an example like this when you have 2 that work out the same. And the solution is to simply pick one more point along the graph and go through the same process again. Obviously ignoring this one because we know this one's definitely not correct. So I'm just going to move up a little bit here and try this point here. So this point has an x value of 3 and a y value of 2. Okay, now going back to this equation where y equals x minus 1, I'm going to replace y with 2. So it's going to be 2 equals, and x minus 1 would become 3 minus 1. So far this is looking good. 2 is the same thing as 3 minus 1. So hopefully this one doesn't work out. I'll replace y with 2. So 2 equals 1/2 times x, and in this case our x is now 3. So is 2 equal to half of 3? No, it is not. So in conclusion, our final answer is this equation, y equals x minus 1, would be the correct one. Because when we substituted our x and y values, for both of the points we tried, it worked, whereas the other ones didn't. Okay, let's go ahead and try 2 more examples, and then we'll be done with the video. Okay. So, first step, we're going to pick a point on the graph. I'm going to go with, let's try this one here. And this point has an x value of 1 and a y value of 4. Okay, first equation, I'm just going to write below here. So I'm going to replace y with 4. In fact, I can do that really quickly here. Just go 4, 4, 4. And then I'm going to replace in my x values with 1s. So this would be, instead of x plus 3, it's 1 plus 3. The next one would be 2 times x, which is 1. So 2 times 1 plus 2. And then finally, replace x here with 1, you get 1 plus 2. Okay. Well, 4 is clearly not 1 plus 2. That's wrong. So it's not this equation. 4 is equal to 1 plus 3, so that one works. And this equation also works because 4 is the same thing as 2 times 1 plus 2. So again, we need to do a bit more work here and try one more point to see. And if I back up a little bit and try this point here, let's see what happens. So this point, this guy here, has an x value of 0 and a y value of 2. Let me just move over a bit. Okay, so back to our first equation, we're going to write 2 equals and x plus 3. Now this time our x value is 0, so 0 plus 3. Well, and look at that, we can tell right away this is not true. 2 is not the same thing as 0 plus 3. So we're done. We just proved that this one does not work, which means this is our correct equation. Okay, one last example, just over here. Okay, I'm going to pick, let's do this point right here. And that has an x value of 3 and a y value of 0. So now let's go through these equations. We're going to place all our x's with 3's and our y's with 0. So we've got a 0 here, a 0 here, and a 0 here. And then x we're going to replace with 3. So in this first one, it's 0 equals 3 plus 3. That is obviously incorrect, so we can ignore that one. Next up, we've got negative x plus 3. Now we know x is going to be replaced with a 3, so this would actually become negative 3, because that x becomes 3. So 0 equals negative 3 plus 3. That's correct. That works. So now let's try this one last equation, and then we'll see what happens. So again, this is kind of like the last one. We're replacing x with 3. That negative symbol will still be there. And we add 4. So is 0 the same thing as negative 3 plus 4? No, because negative 3 plus 4 is 1. So that does not work, which means our correct correct equation was this one here, y equals negative x plus 3. Alright, that's it for this video.